So when you simplify radical, you want to find the largest factor of that number that is either a perfect square or a perfect cube, if it's a cube root. And remember, a factor is what? What's a factor of a number? Yes, so like 49. The factors of 49 are 1, 7, and 49, right? Because all of those numbers divided to 49 evenly. Okay, so with that said, let's write down these first two examples. So we have the square root of 216 and the cube root of 108. So when we simplify this radical of square root of 216, we want to leave it as a radical. So we want to think of, we want to think of a factor of 216 that is a perfect square and the largest factor. So if you look at the rest of the perfect squares, which one of those do you think divides into 216 evenly? Well, 6 is a perfect square, though. But 6 goes into 216 how many times? Wait, 6 goes into 216 3 times? How many times does 6 go into 216? You need a calculator. Grab a calculator. Tanner's ready. Rest of you, grab one. Hurry. Okay, so 36 times 6 is 216. Is 36 a perfect square? Yes, right? Because the square root of 36 is 6. So 36 times 6 is 216. So this is how we're going to split it up. Instead of writing it as the square root of 216, we're going to write it as the square root of 36 times the square root of 6. Because we know 36 times 6 is 216. But we're going to split it up like that because 36, let me erase this now, 36 is a factor that's a perfect square. So what is the square root of 36 again? 6, and then we're still multiplying it by square root of 6. And that is the simplified answer because 6 right here doesn't have any factors that are a perfect square, right? Because the factors of 6 are 1, 2, 3, and 6, but none of those are perfect squares, right? What is the smallest perfect square besides 1? 2, and 2 squared is 4, right? So, let me show you something in your calculators. Oh, don't look here, I gotta clear this. Okay, so if we put in the original problem here, the original problem was square root of 216, right? So if we go Control X squared is the square root button, and we go 216, it will tell us the answer, but it is as a what? Decimal, which we need to know how to simplify it and leave it as a radical, okay? And then our answer was 6 square roots of 6, right? So 6 square roots of 6. Notice it's the exact same thing, but we just simplified it and left it as a radical. So if you're ever sure if your answer is correct, C. You can put in the original problem and put in your simplified answer. They're the same decimal, and you should be correct. Okay? All right, now let's look at number 2. Cube root of 108. So now we got to switch our thinking from perfect squares to perfect cubes. The smallest perfect cube is what? What's the smallest perfect cube other than 1? 8. So 8 is the smallest perfect cube.
Just wondering if that's there when we divide by the square root of 6. Why is it like almost 6?
But that won't happen every time though. That's just Luke with that one. Okay, so think. What number is in the perfect cube that could be a factor of 108? Which one is it? Let's see, 125 is in the factor, so then we go to the next next cube up is 64. Is 64 going to 108? No. What about 27? Do you think 27 divides into 108? Yes, it does. So go 108 divided by 27. I think it does. 4 times. So then, 27 is our perfect cube, so we're going to write that one first, okay? So the cubed root of 27 times the cubed root of 27 went into 108 4 times. So now we're splitting up the cubed root of 108 into 27 multiplied by 4, okay? What's the cubed root of 27? 3. So then it will be 3 times the cubed root of 4. And that is the simplified answer. Okay? All right, sure you still have lots of questions. We're going to keep working. Okay, let's write down 3 and 4. Oops. So number 3 is 5 times the square root of 392. Number 4 is 3 times the cubed root of 250. So now on these, we just have a number multiplying to what the radical is, and I'll show you how to do that in a minute. But first, let's just focus on 392. What is a factor of 392 that you think is a perfect square? When we look at a perfect square chart, sorry Spencer, I won't steal yours anymore. When we look at a perfect square chart here, what's the largest perfect square that we think can divide into 392? The largest factor would be half of it. So then we could start right here at 196. Does 196 go into 392? It's exactly half of it, right? Okay, so that's our number that we want to use. So then it will be 5, we have out in front, times, oops, sorry, let me get rid of this screen, times the square root of, what was the perfect square that we found? 196. So 5 times the square root of 196 times the square root of 2, right? Because 196 was half of 392. And then we just simplify our perfect square. So what's the square root of 196? What was it? 14? So then 5 times 14 times the square root of 2. And what is 5 times 14? I think it's 70, but double check me. Yes. Okay, so 70 times the square root of 2. So that is the simplified answer as a radical. Okay? Like I said, you can always plug this in the calculator, the original problem, plug in the answer, and see if they're the same decimal. Okay? Okay, let's do number 4 now. Cube root. So think 250. When we're looking at our perfect cubes here. So what's the largest perfect cube that could divide into 250? Largest one is the one that's half of it, which is, oops, 125. So then 125 is our factor that we want to use. So then you have the 3 out in front times the cube root of 125 times 125 divides into 250 2 times. Now let's simplify that. So what is the cube root of 125? is 5, so 3 times 5 times the cube root of 2. And what is 3 times 5? 15 cube roots of 2. And when you get the hang of it, and you can skip this step here and just multiply them right here to get your answer, okay? I'm just showing the work. Okay, so let's do some more. So now what if we're adding two radicals like this? So number 5, square root of 5 plus square root of 45. So let's make a note over here. Like radicals, so instead of like terms, let's talk about like radicals have the same root and radicand. Remember, we're looking at like cube root of 7. This is the root, 3 is the root, and the radicand is the 7. Okay? So they have to have the same root, and they have to have the same number under the radical sign, which is referred to as the radicand. Okay? If they don't have the same, then you can't add or subtract them. Just like if we have x plus x squared, can we add those two terms together? No, because they're not alike, right? And we can't add y plus x together because they're not alike. And it's the same thing here. Right now, this square root of 45 plus the square root of 5, they're not alike. They both have square roots, but their number, radicand right here, is not the same. So we cannot add them to be square root of 50. Do not do that. But we can simplify each of them to see if they're the same. So, is that a factor of 5 that was a perfect square? No, right? Because 5 only has a factor of 5 and 1, right? So we can't simplify square root of 5, so we're just going to leave that one alone. But what about 45? Does it have a factor that's a perfect square? 9, right? So 9 is a factor of 45, so we're going to write that as square root of 9 times square root of 5. Since 9 times 5 is 45. Now, square root of 5 plus, what is the square root of 9? 3. So then it will be 3 square root of 5 is what it simplifies to be. And then now look, now are they like radicals? Yes, they're both square roots and they're both having 5. So now we can add how many square roots of 5 we have. We have 1 here, because remember there's an invisible 1 here. 1 square root of 5 plus 3 square roots of 5 is how many square roots of 5? 4. Just like if this was 1x plus 3 x's, how many x's do we have? 4 x's, right? It's the same sort of thing. So 4 square roots of 5 is the final simplified answer. Okay? Questions on that one? Okay. Let's do number 6 now. Cube root of 108 plus cube root of 32. So right now, are these like radicals? No, they don't have a cube root, but the radicands are not the same, right? This one's 108, this one's 32. So let's simplify them. We've already done 108, right? Okay, we already simplified cube root of 108. What was it? 3 cube roots of 4. So let's just write that answer because we did that one already. Plus, now, does 32 have a factor that's a perfect cube? 8, right? 8 is a perfect cube. So then we're going to write that as the cube root of 8 times the cube root of what number am I going to put here? 4, because 8 times 4 is 32. So what is the cube root of 8? Okay, and we need to know that. Cube root of 8, cube root of 27. Those are like the smallest cubes, and you should know those for sure, okay? If you don't now, learn them. So 3 times the cube root of 4 plus 2 times the cube root of 4, because the cube root of 8 is 2. And now, are they like radicals? Yes. Why are they like radicals? Same root and radicand. They both have a root of 3, radicand of 4. So how many cube roots of 4 do we have? We have 5 of them. Okay? Last one in the notes. I know it's been a long notes day. Okay, last one. We're going to mix up cube roots and square roots together. So we're going to write that one down. So cube root of 135 plus square root of 6 plus cube root of 3 plus square root 54. All right, let's try the first one here. 135 cube root. So looking at our perfect cube list, which one of those divides into 135? You think not 64, because twice of that's 128. So then the next perfect cube is 27. Does 27 go to 135? Yes, it does. How many times? 5. So then we go cube root of 27 times the cube root of 5 plus, now 6. Does 6 have a factor that's a perfect square? No. The smallest perfect square, like we mentioned earlier, was 4, and 4 is not a factor of 6, so we just leave that one alone because it's already simplified. What about cube root of 3? Is that simplified? Yes, because there's not a factor of 3 that's perfect cube. Okay, 54, we didn't do 54, we did 45, huh? Okay, so that's a factor of 54 that's a perfect square. 9, right? So we can write this as square root of 9 times square root of 9 times what is 54? 6. Good. Okay, so now we have it written out. Now let's just simplify this perfect cube we have here and the perfect square we have here. So what's the cube root of 27? 3. So we have 3 cube roots of 5 plus square root of 6 plus cube root of 3 plus, what's that last term going to be? How many square roots of 6 do we have? Right there. 3 square roots of 6. Right. Okay, now, do we have any radicals that are alike? Which ones? Yep, the square root of 6's, right? So let's add those. We have 1 square root of 6 plus 3 makes how many? So we have 4 square roots of 6, and then it crosses out now that I've added those together. And then our cube roots alike? No, because one has a 5 as the radicand, one has a 3. So then we just write them. 3 cube roots of 5 plus cube root of 3. And that is our answer, because we can't add any more radicals together. Questions on that problem? Okay, let's do some more on our assignment.